Hello, hello, hello. Today's video is for all of you out there that are having problems trying to understand inputs versus outputs, evaluating versus solving, particularly when it comes to linear equations. Today's video in particular goes out to people who are taking Math 67 at El Camino College in Southern California. If so, this is question number 10 in your practice gateway exam, number 4. First of all, let's notice here what the question says. It says, answer the following questions about the given graph of a function. Draw horizontal and vertical lines on the graph to indicate your work. And then it says, what is f at 15? Let's take a look at the question before we look at the graph. It says, what is f at 15? Notice it doesn't say f times 15 or f divided by 15 or anything like that. It says f at 15, which means we're going to evaluate the function at 15. And that's the kind of language that you're going to read about in a math textbook or maybe here in a classroom. But to better understand it, what we're going to do now is take a look at a gumball machine. We've all used a gumball machine before. You put quarters in the machine and you get gumballs out. Again, you put quarters in and you get gumballs out. So for example, if you were to put 1 quarter in the machine, you'll get 1 gumball. You put 25 cents in, you get 1 gumball. If you were to put 50 cents in the machine, you'll get 2 gumballs. Or if you put 75 cents in the machine, you get 3 gumballs. So we have an input and we have an output. Which is the input? Is the 25 cents the input or is the gumball the input? Which one would it be? Right, the 25 cents is going to be the input. That's what you're putting in the machine. And the gumballs are what you're getting out of the machine, so that's going to be your output. Now, with this in mind, you could see a question like, what is P at 25? What is P at 50? What is P at 75? Each one of these questions is asking, if I put a certain number of quarters in the machine, what will I get coming out of the machine? So now to better illustrate this concept, we have a graph. We have here on the bottom the horizontal axis labeled X. That shows us our inputs, 25 cents, 50 cents, 75 cents, $1. That's the money we're putting in the gumball machine. And on the vertical axis, we have our outputs, F of X. That shows us the gumballs we get out of the machine after we put money into it, either 1, 2, 3, or 4 gumballs, depending how much money we put into it. And then, of course, we have this dark yellow line. That's our function, which shows us the relationship between the inputs and the outputs. Then I've got the questions here at the bottom. P at 25, P at 50, what's P at 75? Let's start with P at 25. What is P at 25? This is basically asking us, when we put 25 cents into this input line, what is our output going to be? So we go to 25 cents on the horizontal right here. We draw a line straight up. And then when we get to the function, we hang a left. And we don't have to go very far. We draw a little arrow. There's 1. That means that P at 25 is 1. We put 25 cents in. Our output is 1 gumball. P at 50. What's P at 50? Well, we put 50 cents in, as we can see here on the horizontal axis. We put 50 cents in. We draw a line straight up the gumball machine, straight up to the function, and we hang a left, and we head over to the vertical axis, and when we get there, we see a 2. That means our output is 2. P at 50 is 2. 2 gumballs for 50 cents. Then 75. Where's 75? Oh, right here. P at 75 means we go to the 75 cents on the horizontal. We draw a line straight up to the vertical axis. When we get to the function, we hang a left and we speed over to the vertical axis. And when we get there, we'll notice that we have 3. That means P at 75 is 3. Now we're going to keep these concepts in mind as we return back to the original Gateway Practice exam problem, where it says, what is f at 15? The first thing we notice is the horizontal axis here at the bottom. That's our input x line, which we've labeled x here. So that's our input line, which is horizontal. And then we also have the vertical, which is our output line, which is f at x, also known as y. And we also, of course, have the function, this dark brown line that's coming across. That's our function. And when it says, what is f at 15, means what is the output when the input is 15. So since the input is 15, we go to this input line. And we count off until we get to 15. There's 5, 10, there it is, 15. When we get to 15 right here, we draw a line. We start here at 15, we draw a line straight up to the function, and then once we get the function, we make a left turn here, and we go all the way across until we get to, looks like 4. So we get to 4, we're going to circle the 4 there, and that basically says when our input is 15, our output is 4. Again, our input is 15, so we go across the horizontal here until we get to 15 right there. When we get to 15, we go straight up, and then we make a left turn, and we go all the way across to 4. And so there's our first solution. What is f at 15? F at 15 equals 4. Whereas in the first problem, we went to the input, we evaluated the function at an input of 15 to find the output. Now guess what? We're going to the output. We're going to the output 12 to figure out what the input is. Because this one basically says when 12 is the output, what is the input? So we go to our output vertical here, 12. We go 2, 4, 6, 8, 10. There's 12 right here. When we get to 12, we draw a line straight across to our function. And when we get to the function here, we come straight down. And we come straight down and we land at 5. Right there. Right there, 5. So we'll circle 5. And again, this basically says when the output is 12, in other words, when our vertical, our output is 12, the input needed to get to 12 is going to be a 5. So what is the solution to the equation 12 equals function of x? X equals 5. And that concludes this video. Thanks for watching. We'll see you next time.